Well, in this chapter, we're going to talk about exponential functions as well as logarithm functions, and we'll show how very much related they are. Let's begin this section talking just about exponential functions. So the definition of an exponential function with base b, that means the base of the exponent will be b to the x power, is defined exactly as I said. F of x equals b to the x. Very simple. B is the base, x is the exponent. Now let's just review just a little bit here. Let's say you have the number 2 and you want to multiply it by 10. Well, that would give you 20. If you take 2 and raise it to the exponent of 10, you get a much bigger number, 1,024. So we're going to see in just a minute that these functions, when graphed, can increase very, very at a good rate compared to something like just multiplying x by 20, having a linear function. So these can increase very, very rapidly. So that's the function with base b, the exponential function. X and b are just real numbers, and b is going to be a positive number, and it wouldn't be equal to 1 because otherwise 1 to any power is just 1, and that would be just a constant function. Well, we will look at more broad functions than just this function. We're going to look at a whole family of functions, and they could they'll look like this, but they might have something like, let me do g of x equals 1/2 times 3 to the x. Okay, so what we're doing here is we have the base of the exponent is 3. The exponent is x always. That's what makes it an exponential function. But you can also have a constant out front. All this means is this would be 1/2 the height or 1/2 the value of a function that was just 3 to the x. And another one, we could even have h of x is equal to 3. I'm just putting a number out front, maybe -3, times 5 to the 2x minus 1. So the function can actually have an exponent that is a function of x in itself. This is like 5 raised to the f of x, if f of x were 2x minus 1. And then this is just the constant out in front. And if we wanted to, we could put a plus 1 out there, which remember what this does when you just tack on a number, adding it on to the end, it just lifts this 1 unit vertically. Whatever the graph of this would be, tacking on the plus 1 moves it up 1 unit. All right, well, let's look at some of the basics of just this exponential function, f of x equals b to the x. The domain. The domain is all the possible x values that you could plug into this. Well, can you have any positive number as an exponent? Yeah, you can. It could be, the exponent could be 0.1119854. The exponent could be pi. It could be any positive number. It could actually be a 0, b to the 0. Any number to the 0 just gives you a 1. And it could even be a negative number. Remember that if you take a to the negative n, that's just equal to 1 over a to the n. This is just one of those exponent facts that hopefully you have memorized. Okay, so the domain is all real numbers. You can plug in any value of x here. And the range, well, the range, if you're taking a positive number, b, and you're raising it to an exponent, even if that exponent is negative, you're never going to get a negative number. So the range is all positive numbers. And how do we write that? We can write it as an interval from 0 to infinity. That basically or exactly means all positive real numbers. Okay, the graph of f is going to pass through, well, what is the y-intercept? That's what I want to put here. If you plug in an x, a 0 for x, you would get f of 0 is equal to b to the 0, which is 1. So the y-intercept is 0, 1. And if b is bigger than 1, so, as an example, f of x equals 2 to the x. Well, if you go from left to right looking at the graph of the function, which we haven't looked at yet, you'll see that it is an increasing function. As one example, if b is the number 3, well, 3 to the 1 is only 3, but 3 squared is 9. 3 to the third is 27. It keeps getting bigger and bigger and bigger. All right? If b is between 0 and 1, that means it's a fraction between 0 and 1. So if you multiply a number by this, it's going to shrink it. In that case, it's a decreasing function. And let's look at an example. Say you take b equal to 1/2. What happens if you square that? You get 1/4. But if you take 1/2 and raise it to the third power, you get 1/8, a smaller number. The larger this exponent is, the smaller the result will be. Now, see if you can remember what to plug in here. F is a one-to-one function. I'm telling you that. Every one-to-one function has an inverse function. And we'll find out later that that's actually the logarithm function. Okay? And then the x-axis, when we graph it, and we'll graph one in just a minute, the x-axis is a horizontal asymptote. All right, well, that's all about the theoretical stuff we need to get out of the way. Let's graph an exponential function or two. Okay, so we're going to graph this function f of x, which is 2 to the x. If b is much bigger than 2, if you get 3 to the x or 4 to the x, the number blows up so quickly I won't be able to get too many points on this plotted in this xy plane here. And then we're going to do, on the same xy plane, g of x equals 1/2 to the x. Now let's do this one first. I've got a table set up here. F of x equals 2 to the -3. Actually, I think I'm going to start with the very easiest one. What is f of x equals, what is 2 to the 0 equal to? That's 1. 2 to the 1 is 2. 2 squared is 4, and 2 to the third is 8. What is it when we raise the number 2 to a negative number? It's 1 over 2 to the positive number of that. So for example, we know 2 to the -1 is equal to 1 over 2 to the positive 1. So that's going to be 1/2. 2 to the -1 is 1/2. 2 to the -2, well, 2 squared is 4, so this is going to be 1 over 4. 2 to the -3, since 2 to the third is 8, that's going to be 1/8. Okay, so for this function, f of x, we now have 8 ordered pairs to plot. -3, 1/8. -2, 1/4, all the way down to 3, 8. And let's go ahead and graph that. Then we'll deal with the function g. Well, I'm going to start here at 2 to the 0 is a 1. And I'm going to go 2 to the 1. So if x is a 1, we go up to 2. If x is a 2, we go up to 4. If x is a 3, we go up to 8. Notice if we went one farther, 2 to the 4th, would take us all the way up to 16, which would be way off of this graph. Now let's go backwards. 2 to the -1. If x is a -1, the value of the function is a 1/2. And then at -2, it's a 1/4, and so on. So it gets very close to the x-axis very quickly, but as you go towards -infinity, it just keeps getting closer and closer and closer to the x-axis. And that shows that the x-axis is an asymptote, a horizontal asymptote. So let me see if I can graph this. I'm just trying to keep it barely above that x-axis. All right, so this looks like f of x equals 2 to the x. That graph right there. And again, I should put an arrow here because it goes up forever. It continues to get taller and taller. All right, well, before we make this table of values for g of x, let's notice that, what's another way of writing this? I kind of already said it. You have a fraction here. This is the same thing. It's equivalent to writing g of x equals 2 to the negative x. Remember what I said the negative sign does? The negative sign, if you want to get rid of it, you just put 1 over. You take the reciprocal of this number, 1/2 to the x, which is exactly this. So we won't actually have to do all the computations because we've already done them. If we think of g of x being 2 to the negative x, well, if x is a -3, negative x would be a +3, right? So this is going to be 8. Maybe I'll go ahead and write 1 or 2 of them. Should I write it? I'll write 1/2 to the -3. That means take the reciprocal of 1/2 to get 2, and this is equal to 2 to the 3rd, which is 8. So instead of 1/8, we got 8. Instead of 1/4, we're going to get 4. Instead of 1/2, we get 2, and then we get a 1. And then instead of 2, we get 1/2, and then 1/4, and 1/8. And let's just verify one of these at the bottom. This would be 2 to the -3. Because x is a 3, and we're plugging it into 2 to the negative x. 2 to the -3 is 1 over 2 to the 3rd, which is equal to 1/8. I'll let you fill in all those. And let's now plot. And now what are the ordered pairs? When x is a -3, g of x is 8. So -3, 8. -3, 8. Okay. And -2 is going to be 4, a height of 4. -1 has a height of 2. 0, 1. Well, this point they both have in common. 1, 1/2, and then 1/4, and 1/8, and so on. So let me draw this. And we shouldn't be too surprised that these are symmetric about the y-axis. They're mirror images. If you flip one over, you get the other one. And this is, let me write this as g of x equals, and here maybe I'm going to put 2 to the -x. If you remember in our transformations of functions, if you replace x, the function, if you replace x with -x, that just flips it around the y-axis. So we get two graphs that look just like this, mirror images of each other about the y-axis.